Hello, Assalamualaikum, and very good day to all of you. So today we're gonna start new chapter, which is chapter radiation. Okay, which is in chapter 4. Okay, for your information, for chapter radiation, I will arrange it and divide it into three different parts. Okay, for the mechanism of heat transfer through radiation is slightly different compared to the one which is occur in conduction and convection. For both type of heat transfer, which is conduction and convection, it needs medium. Okay, conduction it needs a solid medium. Convection it needs medium such as liquid or gas as a medium for convection. Okay, but again for radiation it is transferred through electromagnetic wave. Okay, and the easiest way to find example of the mechanism of heat transfer is the heat from the sun to the earth. That's why during the hot season or during very hot weather, very on a sunny day, okay, we feel the heat on our skin and make us exhausted because there's a radiation happen. So the objective in this chapter is we want to know and we want to learn how can we determine the heat transfer due to the radiation. How much is the heat transfer? Okay, the theory or fundamental equation related to heat transfer due to due to radiation is given by Stefan Boltzmann equation. Well, this is the equation. Okay, but if you can see that we have two parameters which is we are not really used in conduction and convection, which is sigma and epsilon there. The sigma there is actually the Stefan Boltzmann constant, and in fact this value you can actually get it from calculator. Okay, explore your calculator to have a look at how can you get this value. Okay, and the second one which is this epsilon, which is represents the emissivity. If it's the black body, the emissivity is equals to 1. If it's less than, if it's gray body and the value is less than 1. Okay, for your information, the unit for radiation, the Q here is actually joule per second. Okay, let's try with the example 1, the super easy example here. Okay, so how much is energy is radiated by the object in 10 minutes. Okay, this is the object, so the question asks you to determine how much is the Q transfer by this object. Okay, so solution. First, of course, we need this equation of radiation, and we need to know what is Q. So as usual, just check the parameters needed in the equation. Okay, for example, A is given there, which is 5 square meters, and epsilon is 0.8, and the temperature is 500 Kelvin. So just substitute in the value into the equation. Okay, so this is the value. If you remember in the previous slide, I do mention that the unit here is actually joule per second, but the question here asks you to determine how much is the Q which is transferred in 10 minutes. So that's mean the time here the can be bring to the on the right side of the equation. Okay, where in this case 10 minutes is actually here 600 second. Okay, so that's why the answer is just in joule, because we want to know how much Q in 10 minutes. Okay, let's do example 2, which is also considered as an easy peasy example. Okay, the question asking about temperature of the sun. Okay, this is the diagram and the information is given here. where if you can see here, the distance from sun to the earth is given, which is represent this distance, okay, and the Q is given and emissivity is given, and also the radius of the sun is given in this case, okay. So how can we get the temperatures of the sun? Okay, according to the equation for Stefan-Boltzmann equation, okay, this is the equation. So we want to get the temperature of the sun, where in this equation is the terms of T there, okay. So Q is given, and area, so area of the sun, the surrounding area of the sun can be calculated by using this formula, okay. But be careful with the R term here. R term here is actually the radius of the sun, not the distance of the sun, okay, where the area is actually means the source, the area of the heat source, where in this case the heat source is actually from sun. That's why R is actually radius of the sun, according to the formula here, 4 pi r square, okay. So epsilon is equals to 1, okay, and of course the sigma is just a Stefan-Boltzmann constant, where you can just get it from calculator. And there we go. Lastly, we get the value of sun temperature is actually 5375 Kelvin. Okay, we finished part 1 for chapter 4. Okay, so we'll see you again in part 2.